Hi everyone, in this video we'll be looking at prime factors. We'll begin by exploring the definition of what a prime factor is, and then we'll move on to looking at how to express numbers as a product of their prime factors. And then after that we'll look at how to find the HCF and the LCM using the prime factors decomposition. Okay, so let's make a start and look at the definition of a prime factor. So a prime factor is basically a factor of a number which is also prime. Now, every number can be expressed as a product of its prime factors, okay? So we'll just take a look at some examples now of how that's done. So example 1, we'll take a look at the number 42, okay, and use like a tree diagram and decompose it into its prime factors. Now, the easiest way to do this is because it's an even number, I can see it's 42 ending in a 2, it's got to be a multiple of 2. So I can put 2 down straight away. And then think about in 2 times table, when does 42 come? Okay, so 42 divided by 2, or if we just half 42, it is 21. Now, out of these two numbers, one of them has got to be prime, and that is our 2. So we're going to circle it so that we can keep a record of all the prime factors. Okay, then moving on to 21, let's break that down as well. So that comes, we know, into 3 times table, and it's 3 times by 7. Now, both of these are prime, so we circle both of them, and this is where we actually stop. Okay, this is how we know when we need to stop our prime factor decomposition. That is when you arrive on 2 factors which are both prime, because we cannot break them down any further. Okay, so that's where we stop. Okay, so I can express 42 as 2 times by 3 times by 7. Okay, and these are all of its prime factors. We can check that we've done it correctly. If we do 2 times by 3 times by 7, does it give me 42? Well, let's check. 2 times by 3 gives us 6. 6 times by 7 does give us 42. So therefore we know we've actually decomposed 42 correctly into its prime factors. Okay. Okay, now next let's take a look at one more example. Okay, so we'll look at 63, an odd number, and see how we can decompose that. So 63, let's take a look at which times table it comes in. So we can't do 2 as its prime factor because it's an odd number. Okay, it ends in a 3. So we'll take a look at 3 times table. Okay, so I can circle my 3 because I know that's prime. Now 63 is actually going to be 21 times by 3. Okay, and now I know that I can break down 21 further because it's got factors. Again, I can come into the 3 times table, so I'll circle my 3 again, and it's going to be 3 times by 7. Okay, now both of these are prime, so I know that I've got to stop there. Okay, and now I'll just rewrite 63 as a product of its prime factors. So starting with the smallest number, it's 3, the smallest factor, times by another 3 times by 7. Now, if you look here, you've got lots of 3s, okay, which is the same factor that we're using. And there's a clearer way of representing this. So we can use index form to show that. So we can do 3 squared, because there's lots of 3s, multiplied by 7. It's just a nicer way of showing the same thing. Okay, so now we'll take a look at some examples of how to find the HCF and LCM of 2 numbers by using prime factor decomposition. Okay, now let's take a look at example 1. So find HCF and LCM of 42 and 63. Okay, now both of these numbers, 42 and 63, we've looked at in the previous example, Okay, we looked at how to be doing the prime factorization of them. So just to make things quicker, we'll just use the same numbers in this example. So if we recall, 42's prime factors were 2 times by 3 times by 7, and 63's were 3 times by 3 times by 7. Okay, now we can use Venn diagrams in order to show these, in order to work out the HCF and the LCM. Okay, so here's my Venn diagram of 63 and 42. Okay, now we can start filling this in with our prime factors located at the top. And the way to fill it in is if we start off by looking at the center where the intersection happens of our two circles. By that, what we mean is in the intersection we'll be putting in the prime factors that are common in both. Okay, so I'm just going to take a green pen and underline the common prime factors. Now I can see that there's a 3 in 42 and there's a 3 in 63 as well, which is common. There's one set of them. Okay, so that means I'll just be putting 1 3 there in the middle. Now I can also see that there's a common 7 in both of them. I'm going to go ahead and put that in the intersection as well. So I've got a 3 and a 7. Now the rest, the 2 and the 3, okay, I'll underline that with a different colour because they are not common in 42 and 63. So I'm going to put them in their respective circles, okay? So in 42 only we've got a 2, and in 63 only we've got a 3, okay? So that's the way of filling in your Venn diagram. And now we'll take a look at how to use this Venn diagram in order to work out the HCF and the LCM. So the HCF stands for what is the highest common factor, okay, of 63 and 42. So we want the highest common factor. We'll do that by looking at the 3 and the 7 that's in the middle, okay, because they're common in both. So what we're going to do is multiply my 3 by my 7. That gives me 21. That means that 21 is the highest common factor of both 63 and 42. Now we'll look at how to work out the LCM using the same Venn diagram. So LCM stands for the lowest common multiple, okay? And by that I mean what is the smallest possible number that is common in both the 63's timetable and the 42's timetable, okay? The way to work that out is just multiplying all of these numbers together in my Venn diagram, okay? So that means I'm going to be doing 3 times by 3 times by 7 times by 2. So I'm just going to take all of these and multiply them together. So that gives us, now it is quite a lot of multiplying and it will be a bit of a big number. So the easiest way to do this is if we look at 3 times by 3 times by 7, well, I know that if we look at above, is just 63. Okay, so that means all I'm doing is 63 times by 2. That's left over. So if we double 63, we get 126. Okay, so that means that the lowest common multiple of 63 and 42 is going to be 126. Okay, so the next example is we've got brand new numbers. Okay, so 28 and 45. We're going to work out the HCF and LCM of them. Now, these two numbers, we've not looked at their prime factor decomposition in the previous examples. That means we've got to start from step 1, which is to do the prime factorization, okay, using the tree diagrams. So I've got, that means 28, and I'm going to break that down into its prime factors. So since it's an even number, I can go ahead and half it, okay? So that means it's going to come in 2 times table, and half of 28 is 14. So that's where I'm going to leave it. I'm going to break down 14 a bit more. So 14 comes in the 2 times table, and it's 2 times by 7. Now both of these are prime, so I'm going to circle them. Okay, and that's where I stop because I cannot break down these two any further. So that means 28's prime factor decomposition is 2 times by 2 times by 7. Okay, and then the next number is 45, And let's go ahead and do the prime factorization of that. So we can see that it's an odd number, so I cannot just divide by 2, okay, like I'd like to. Instead, because it ends in a 5, I'm going to go ahead and use 5 times table. So 5 is a prime number. I'm going to circle it, and we know that 5 times by 9 gives us 45. Now 9 is not a prime number, so I need to factorize it further. And I know that's 3 times by 3, and 3 is a prime number, so I'm going to circle both of my 3's. Therefore, 45 equals 5 times by 3 times by 3, or 5 times by 3 squared. Now, the next step is going to be doing my Venn diagrams, okay? So I've drawn a circle for 28 and a circle for 45, and a place where they overlap. Now, let's go ahead and look at what is actually common in both. But before we do that, I'll just go ahead and rewrite 28 and 45's prime factors so we can check what's common in both. So we've got 2 times by 2 times by 7, and then for 45 I've got 3 times by 3 times by 5. Okay, and if we take a look at the two sets of prime factors, I can see there's nothing common, so I can't put anything in the center or the intersection of my Venn diagram. Okay, that means instead I've just got to go ahead and fill in the circles with the prime factors. Okay, so for 45 it's 2 3's and 1 5, and for 28 it's 2 2's and 1 7. Okay, now if we take a look at the HCF of these two numbers, well, since there's no number in the middle, we cannot force there to be a common factor. That just means that there is no highest common factor. So we'll just write down no HCF, okay, in this scenario. And for LCM, well, LCM, remember, it's just all the numbers in your Venn diagram multiplied together. So that means it's 2 times by 2 times by 7 times by 3 times by 3 times by 5. Okay. Now, instead of doing all the multiplication, okay, I've just broken it down and said that 2 times by 2 times 7, well, we know that's already 28, so I can just put that there. And 3 times by 3 times by 5 is already 45, as we know from above. So it's basically a case of doing 28 times by 45, okay? Now, we could use any sort of long multiplication method in order to work this out, or the grid method, okay? So that should be giving us 1,260, okay? Now, this was a bit of a tough example in the sense that there was no HCF, and also we had a bit of a big multiplication calculation to do. Also, a key point to remember in this example is that when you've got two numbers that don't have a HCF, it means that they are co-prime, which means that they don't have any common factor other than 1. So lastly, to finish off, we'll be looking at an exam question, okay, to do with HCF and LCM, so you get an idea of how it's applied in the exam. So we've got two values, okay, two unknowns. A equals 2 cubed times 3 times 5, and B equals 2 squared times 3 times 5 squared. And the question is, find the HCF, so the highest common factor, of A and B. Okay, and we don't know what A and B are. We've just got to use their prime factors or prime factor decomposition in order to work it out. Now, the way to do this is there is more than one way, but we'll just look at the way that we've currently been doing using the Venn diagram. Okay, so we'll look at rewriting these prime factors without the index form version. Okay, so if we look at A, instead of doing 2 cubed, we can write it as 2 times 2 times 2. You know, there's 3 lots of them. And we've got 1 3 and 1 5. And then similarly, if we take a look at B, that is 2 times by 2 because it's 2 squared. And we've got one set of 3 and 2 sets of 5, okay, because it's 5 squared. Now that I've written it like that, I can go ahead and see what is common in both of my numbers, okay? And I'll just go ahead and underline the common pairs. So we've got one set of two sets of 2s. We don't have a third common one. Then we'll look at, we've got one set of 3 that's common, and also one set of 5 that is common. Okay, now I'm going to go ahead and draw the Venn diagram and help us and fill it in order to help us work out what is the HCF. Okay, so if you remember, the HCF meant that we're just looking at the middle of our Venn diagram. So we'll go ahead and fill the middle section in with what is common in A and B. So basically what we've underlined with our red pen. Okay, so I know I've got one set of 2, so I'll put that in. Another set of 2, one set of 3, and also one set of 5. Okay, so I'll go ahead and squeeze that in there. So that means that the HCF is just 2 times by 2 times by 3 times by 5. Okay, so that 2 times by 2 is 4, times by 3 gives us 12, and 12 times by 5 gives us 60. So this brings us to the end of our video, and if you found it helpful, don't forget to give it a thumbs up and also subscribe for weekly videos. Thank you for watching.